Welcome to this interesting series on continuous compounding. Here we will be discussing 9 scenarios in total just with regard to continuous compounding, and we are starting with first scenario. In this scenario we are trying to understand how continuous compounding actually works. But even before we get there, let us understand how compounding in general works. Suppose I have some money here. Present value is the value given at point 0, or we can call it now, right? So in compounding, what happens is we have to specifically pay attention to the frequency of compounding. So suppose compounding is happening monthly, it means present value will be subject to an interest rate, maybe say 10%. Annual stated rate is 10%. Then we will calculate the future value at the end of the month, which is the first month is January, right? Now this value will be used to calculate the interest for the second compounding period, and then we will calculate the future value at the end of February. Now this will become the base value, and then we will calculate the future value at the end of March. And then this will become base value, and so on. We will be compounding this present value 12 times in a year, and finally we will find out the future value at the end of the year, which is December 31st. So if compounding is happening 12 times, or I should say monthly, then n would be 12. It would be compounded 12 times, right? So the base will change 12 times. So first of all, we will calculate interest on present value in the beginning of the year. Next time we will calculate interest on the future value, which is there at the end of January, and next time we will calculate interest on the future value at the end of February, and so on. So this is monthly compounding. But in continuous compounding, these compounding frequencies are very small. These are infinitely small, right? So in continuous compounding, the number of period becomes infinitely small. So in TVM row of the financial calculator, we must enter a very large value for n, maybe 100,000 for computational purposes. So this way we will be able to solve for continuous compounding. But mathematically, annual compounding and continuous compounding are very different. In annual compounding, if we have to find out future value, then future value is nothing else but present value times 1 plus r and exponent n. So here r is rate of interest, or sometimes some books also use I as rate of interest, 1 plus I exponent n. But in continuous compounding, this formula changes. And in continuous compounding, since number of compounding periods is infinitely small, therefore the formula is present value times E exponent RT. R is the continuously compounding rate and T is the time. So let us do this question. Let us take an example to distinguish between annual compounding and continuous compounding, so that we get the hold of this concept, continuous compounding. So suppose present value is $10,000 and the rate of interest is 10%. So here we get, and compounding period is 1 year. So the future value will be 10,000 into 1.1, which is $11,000. But in continuous compounding rate, present value will be multiplied with e exponent r. R is continuously compounding rate, and let us assume that continuously compounding rate is 10% and t is 1. So we have this number 10,000 times e exponent 0.10. So this we have to solve with help of financial calculator or the financial app. Let us clear everything. Second, clear TVM. Second, clear work. So to do this interesting calculation, I am going to change the number of decimal places to 8. So to do that, I will click second, format, 8, enter, second, quit. So this way I have set the calculator to 8 decimal places. Now let us do this calculation. I will enter 0.10 times 1. This number remains the same. So second EX. And then I have to times it with $10,000. So I get this number $11,051.71. So this is the future value, $11,051.71 approximately. So this is the future value of $10,000 if interest is compounded continuously and stated annual rate is 10%. Now we can do the same interesting calculation as I said earlier also here with n as very high number. So let us do it this way. So here I will clear everything. Second, clear TVM. Second, clear work. 10,000 I will enter as present value. So we are now actually using the second method, which is the TVM row method of calculating the future value for a given continuous compounding rate. Previously we used a formula method, but now we are using TVM row. So I entered 10,000 in the present value, and IY would be 10,000 divided by a very high number for n, and let us take it as 100,000 today. So this value comes out to be, which will go into IY, and n we have to take very high, which is we are taking as 100,000 today, and then I will compute future value. And interestingly, you will see even with the TVM row we got the same answer, $11,051.71. So future value when we are doing continuous compounding is happening in such a way that in continuous compounding periods become infinitely small. So we have to enter a very large value for n, and if we are using TVM row we can take n as 100,000.